Hey everybody, welcome to a brief introduction to Go. In this video, I'll be showing you some of the features that make Go a great language, some of the things that really make it stand out. I'll be discussing a bit of Go's history. I'll show you a code demo where I'll be solving one of the exercises on Go's Exercism track, and I'll finish with listing some of the resources that you can use to learn Go. I'm excited, so let's get started. Go was developed by Robert Griesmer, Rob Pike, and Ken Thompson at Google. They noticed that at Google, there were issues with existing languages where they were either very clumsy or they were unmaintainable or they didn't scale well. And they felt like maybe if we write our own programming language, we can solve all these issues. So Go was aimed from the beginning to be highly scalable, lead to very maintainable code, and it will have great concurrency features because it should run at scale. The language is a general purpose language, so you can build almost anything with it. It's currently mostly used for backends and CLI applications. And a lot of very cool stuff has been built with it, including Docker and Kubernetes and CLI tools like ESBuild, which is a highly performant way in which you can compile JavaScript/TypeScript. The language itself is strong and statically typed. It is mostly an imperative/procedural language. It has object-oriented-like features, but it does things differently. For example, there is no inheritance in Go. One of the key goals of Go was for its syntax to be simple enough to be remembered by a programmer easily. So the entire syntax should be able to be memorizable for someone working with Go, which would make using the language a lot easier. Let's go over the reasons why Go is a great language. First of all, it has a garbage collector. This means that you get memory safety. You don't have to bother with looking at which resources you need to free, etc. So if there are dangling pointers, none of that. Go will take care of that for you, and that's incredibly liberating and very pleasant to use. Another great feature of Go is that it's fast, and it's fast in different ways. The runtime is fast, the compiler is really fast, it has a fast testing framework, and a thing that I really appreciate is that the testing framework has benchmarks built into it. So you can't just write normal tests with the test framework, but you can also write benchmark tests. So you can, by default, benchmark your code and see how it compared to other things and have it be run as part of your regular testing run. And this shows to me that the Go people really want you to take performance seriously. And I think that's a very admirable thing, especially because it's one of the goals of Go is to be performant and to run at scale. And having a benchmarking system built into the testing framework really helps with that. Another thing that is excellent about Go is that it's very minimal. I mentioned before that part of the aim of building Go was to have syntax that you can keep in your head. So it shouldn't be too complex. And this minimal approach to Go has a lot of beneficial results. So one of them is that there's little syntax, so it's easier to pick up. If you start out with Go, there's only so much that you need to learn. It also has the advantage that if you are building something, there's often only one way to do stuff. And that's really liberating because you don't have to choose. And that sounds silly, but it is really a benefit of working with Go code. So this one way of doing things approach also is beneficial if you're reading other people's code, because it's highly likely that they will be writing the same code that you are writing. And that's just, that makes it really maintainable at scale because there will be less variation in how people write Go. And that is also due to the fact that Go is very opinionated, which is another thing that I really like. So Go has strict guidelines on how you should be writing Go. And part of that is encoded in the language, in not having the different syntax options that other languages would provide. But there's more. There's also documentation on how you should be writing Go code. So there's a list of idioms that you should be using. And there's a pervasive use of the format, so Go format. So Go code will be formatted using Go format. Everybody does it. And it will lead to similarly formatted code. So once again, this reinforces the fact that Go code will look similar across different code bases, which makes it much easier to get started with different code bases or to learn new code bases. The documentation is great. These idioms are all documented well on the website, and they have a lot of cool stuff just to have you be coding the Go way. So there is a Go way of doing things. I also really like that Go has a lightweight type system. So whereas other languages might opt for a very powerful, big type system, Go has quite a lightweight type system, and that makes it really easy to use with. There is no inheritance, for example. Go has a nice way of doing type inference, and it's just a very, almost like a dynamic language feel because it's so minimal. And that's a really cool thing that you can use in your code base because it's really fun to play with. Go is also an all batteries included language. So if you install Go, you get a formatter, you get a linter, you get a build tool, you get a package manager, you get a ton of stuff. So there's so much that you get out of the box that makes it easy to get started with Go. And this all helps with doing things the Go way. And finally, Go is really portable. So it's very easy to do cross-compilation, and applications will result in a single binary that's easy to distribute. And that makes Go a perfect solution to, for example, be Dockerized or whatever, be distributed at scale. Let's go over the standout features of Go. First and foremost is Go's concurrency story. Go has a couple of features, and mostly Go routines and channels, that make it incredibly easy to write code that runs in parallel. A Go routine is a way of taking a little bit of functionality and running it in parallel to your other code. So you could have a very large calculation and then have 100 different Go routines all work in parallel to solve that calculation. And it's very easy to create these Go routines. And that's the thing. Go makes doing concurrency easy. And normally it's not easy to do concurrency, but it's hard. And this is where Go really shines. The second concurrency feature is channels. And channels are a type-safe way of allowing communication between all these Go routines. And it's very easy to start with channels. It's easy to start with Go routines and integrating them together. So if you want to build a highly concurrent system, Go is an excellent choice. A second standout feature is Go's structural typing via interfaces. I mentioned before that Go does object orientation differently, and this is also true for inheritance. So in Go, if you have an interface and you have a type, you don't have to say that this type implements that interface. You just have to have that type implement the functions within the interface. You don't have to mention the interface. If a type implements the functions of an interface, is considered to be implementing that interface. And this is all checked at compile time. It's similar to duck typing, but as said, duck typing is often checked at runtime, whereas with Go, it's all checked at compile time. And it's a very, very lightweight way of implementing interfaces and functionality. And it's very, very cool to use, and it's almost liberating, I'd say. And then the third standout feature is error handling. In Go, errors are common values, just like anything, and you have to handle them in your code. Anything that can go wrong will return an error, and you will then have to decide in your code how to handle that error. You can't really forget about handling an error. You just have to do something with it. And this explicitness and this forcing you to deal with errors makes Go application really robust, which is very important for any application, of course, but especially if you want it to be scalable like Go is. So error handling, another great benefit of working with Go code. Let's look at some actual Go code. What I'll be doing is I'll be solving the parallel letter frequency exercise of the Go track. This exercise is about taking a number of texts, a number of strings, and then counting their letters in parallel. So it should be efficient, it should be in parallel, and we will be doing that using Go routine. So it's perfect for showcasing what Go can do concurrency-wise. So let's get started. This is our stub file, our starting point. Before we look at the code, I'd like to mention that I'm using the Goland IDE, which is a JetBrains IDE. I really like it, but you can choose whatever IDE you prefer and it will all work well. So for now, let's just use Golang and let's see what we already get. So one of the things that we get is a type that's called fragmap, and it's a map of runes to ints. A map is something that other languages might call a dictionary. So you can see this as a mapping of runes to integers. So what are runes? Well, rune is a Unicode code point, but for our purposes, you can read that as if it was saying this is a character. So you can see this as a mapping of characters to their frequencies. So runes to integers. The second thing that we have is a function called frequency. And the function frequency takes a single string parameter and it returns a frequency map. And of course, this is the function that goes over all the different runes, the characters in the string, and then counts their frequencies. So let's see how it does that. So first it creates a new frequency map, and then it iterates over all the characters in the string. So with the string, you can range over two things. So the first thing is the index, and the second thing is the actual rune. So we don't care about the index, so we're using underscore, which is like a I don't care about it, but we are interested about the actual rune. So we're saying, hey, for this rune, increment the frequency, and at the end we return the frequency map. So this bit of code iterates over all the runes in the string, and it will count their frequencies. So we already get that. We don't have to write it ourselves. So thank you, Go. So the next thing that we look at is the bulk of our what our logic will be implementing, which is the concurrent frequency function. And this function takes a slice of strings, which means multiple strings. And it returns a single frequency map. And this is, of course, where we need to implement our logic. We will have to determine the frequencies of the individual string slices, and then we will have to combine them to put the frequencies together. And that's what we will be doing. Let's implement the concurrent frequency function. The first thing that we need to do is to do some bookkeeping. So in the end, we return a frequency map, so we have to have some variable that will hold that frequency map. So let's start out with defining that via res : equals make frequency map, and in the end, we will return that resource. So we have now a variable that will store our frequency map, but we don't yet populate it. So we will be using Go routines to process the frequencies in parallel. And if you are using Go routines and you want that Go routine to return something, you are using channels. So channels are a way for us to get back what the Go routines are calculating. So the Go routines communicate with us via channels. So we need to make a channel. So channel : equals make, we use make again, and this will be a channel of frequency maps, and it will be of buffer size 10. So this is the channel that we will be using for our Go routines. Then a Go routine is a function that executes in the background. So we need to define a function that will execute in the background. So we'll call this func Go frequency, and it will take the string to process, and it will take the channel. So that's a channel of frequency map. And in this channel, in this function, we need to do two things. We need to calculate the frequency, and we need to communicate that to the channel. So what you can do is we can say the channel, and then there's this syntax with the left arrow where you can pipe data into the channel. So and then we can just call frequency with the string. And this is saying calculate the frequency and put the result into the channel. So we're now sending data into the channel. We can then use this function for our different inputs. So we have the string slice here. So we're going to do another for loop here. We're not interested in the index. We are interested in the actual text. : equals range of L. And now we're going to start the Go routines. And you do that via the Go keyword. So we're going to say Go, and then our Go frequency function. And then that takes a string and a channel. And we now have the code to set up all this channel logic where we create Go routines, and the Go routines will calculate the frequency, and they will send the result of the frequency calculation into the channel. So that's fine, but we don't yet get the actual results. So that's the next thing that we will be doing. So now we need to extract the information from our Go routine. So we'll do another for loop. And this time we'll just do a regular for loop. So we can do for I equals 0, I is less than the length of the strings, and I plus plus. So just a regular for loop, because we don't care about anything about the actual text, just that we need to, for each of the text, we need to get its value. So this, we need to execute this, the length of the actual slices parameter, because that is how many Go routines we started. So, and then we can say, so resource for, well, what do we do here? So how do we read from a channel? So actually you do that via a very, it's almost the same as getting data from the channel, but it's the other way around. So this is the data. So this is the processed data. And then we can iterate over that, because that processed data will be a frequency map. So we can say a map was from a rune to the frequency. So we're going to say r, frac, colon equals range process data. So this is, just to be clear, this is reading from the channel. So this will be one of the results of the Go routines. And then we can range over the map that is returned and update our eventual resource. So we're going to say resource r plus is frac, and this should actually be everything to it. So let's see if we get our test passing, and then we can look at some things in more detail. And it is, and you can also see how incredibly fast it was. So just let's go over this one more time. So we're creating a frequency map, we're creating a channel where the thing that we are communicating via the channel will be a frequency map. Then we range over all the strings that are in the input parameter, and we start a Go routine for each and every one of these texts with the channel as an argument. Then we will loop through every single one of loop times the number of values in the parameter. We read data from the channel. So this is process data is a frequency map. We then range over that frequency map. So this is basically merging the result of what the Go routine calculates with our end result. And in the end, we return it. So we now have a way to read, to create the Go routines and to read from them, all whilst being very minimal code. And we don't have to bother about any of the concurrency details because Go handled that for us. One very cool thing that this exercise has is performance tests. So if you look at the tests, and at the end, there are two benchmark tests. So one for a sequential version, which just directly calls the frequency function, and one for the concurrent frequency function. So we can run these tests by doing go test dash bench equals dot. And this will run some logic in the background. And in the end, it will finish. And it will give us some information on which of these benchmarks was faster. And the thing that we are interested in is the last column. So this is the number of nanoseconds per execution. So you can see that the sequential one is almost 1.7 times slower, even a bit more. So you can see that concurrent processing was actually faster here. But the great thing is that you can verify that via benchmarks. So that's a lovely thing. We can do some refactoring here too. So let's do that. So for one, this helper function is kind of silly almost. We are almost not doing anything. And we can do this in a different way. So Go allows you to define anonymous functions. So we're going to say, instead of doing, I'll just leave this here in the comments so that you can see the difference. We will be doing func. We'll define a function within this function that takes the the text. So that will be the string. And it will do everything that this function does. So we can copy this here. Then we can call this function with the text value and put go before it. So this is basically exactly the same thing that we did with calling go and then go frequency in a separate function, but only we do it in a slightly different way where you have an inline function. So this is a more common way of doing this because we're merely wrapping things to be able to call it via go. So this is a somewhat shorter way of writing this, and I like this quite a bit. We could also do this. So we can get rid of that intermediate variable, and then we have a nice way of simplifying things. So we're going to go run go test, and it still all passes. And did you see how incredibly fast this test run was? It's almost instantaneous, and that's one of the key benefits of using Go is that it's incredibly fast. So this is our final implementation with just, I don't know, 15 lines of code or something like that. We have a fully parallel way of processing these these frequencies, and all while Go does all the heavy lifting for us. So excellent work, and I think this is a fantastic feature of Go. If you want to write concurrent software, Go is definitely one of the best languages to do it in. Finally, I'd like to show you some of the resources that you can use to learn Go. Obviously, you can learn Go on Exercism. The Go track has 137 exercises, which is huge. Of those exercises, 27 of them are learning mode exercises. So if you go to the syllabus, you'll see that there are a ton of Go concepts covered via these learning exercises. So if you want to learn Go, use the syllabus and you start out with the basics and slowly you build up your Go language. You learn about slices, you learn about a ton of different Go things. And when you finish the learning mode, then you can continue working on the other exercises just to further hone your Go skills. You can also use a tour of Go, which is an interactive way of learning Go, where you have on the left side, you have a little bit of a description of what it aims to teach you. And on the right side, you can then actually have runnable code. You can also use Go by example, which is a collection of articles and examples on a wide variety of topics. So almost everything that you can do in Go is here. And we highly recommend you trying this out. And then finally, I want to mention Effective Go. I've mentioned the fact that Go is opinionated and that there is a Go way. And if you want to learn about those idioms that are recommended, you go to Effective Go. This is a document that contains a ton of features on formatting, on naming, etc. And this is basically a distillation of the Go idioms. If you want to write Go like a Go programmer would, go to Effective Go, read all these guidelines, and you'll be set up well to become a proper Go programmer. And that's it. We've come at the end of the video. I hope I've been able to show you the beauty of Go and that you're now keen to try out Go. So go to Exercism Go track, join the track, and start doing some exercises. And hope to see you soon. Bye.